Good morning, everyone. Good morning. Okay. Okay. So last class we have done on problem on bend tendons, and today we will be doing the this thing tendons with parabolic profile. Okay. So good morning. Good morning. Yeah, let me take the tendons also. Section. Chapter 15 minutes. Okay. Let me share my screen directly. I will go to the so so today we'll talk about the tendons with parabolic profile. Okay. Hmm. So in the previous classes, what we had done, we had gone through the tendons with this triangular profile. But now we have to see what there can be some tendons we have when with a parabolic profile, okay, which will give upward forces, which will give upward thrust per unit run. Okay, so this is a figure that shows that pre-stress beam is carrying an external uniformly distributed load here. Wait, uniformly distributed load. That means this is W per unit run here. Okay, so the tendon here, which is provided here with the parabolic profile, what will happen here? When this cable is provided with the parabolic profile, it will exert a uniformly upward pressure WC per unit run. That means if this is the W, which is UDL here, then whenever we are providing a parabolic profile, what will happen? This parabolic profile, when you give a pre-stressing force P, what will happen? There will be an upward pressure per unit run. Okay, this parabolic profile tendon will provide an upward thrust per unit run in this way throughout the this cable, and due to this, what will happen? Your this uniformly distributed load is also going to act per unit run. You know this. That means what? That is nothing but your down upward pressure, which is this one, due to the tendon, which is parabolic in nature here, parabolic profile. What is happening? You are these upward pressures are trying to these upward forces are trying to counterbalance this downward forces per unit run. This force, this will try to counterbalance this will try to counterbalance this. See here also you can see this figure here. This in this way your WC is per unit run, acting per unit run, and your UDL from the dead load of the beam is also going to act here. That means nothing but your upward pressures are counterbalancing these, trying to counterbalance these loads, okay, these downward loads here. Okay, so this is the downward load which will be acting per unit run. This is a parabolic profile with a dip of h. Okay, below this end sections, these are your end points of the this thing beam cable. Okay, now we already know that in the theory of cables, which is carrying a uniformly distributed load on the whole span of the beam. Okay, so what is happening? We know that the horizontal reaction, which comes here due to the this in cables, you will see there will be a horizontal thrust which is given by WC L square by 8H, where you know this H is this portion, which is the dip of the cable at the center here. Okay, now we know this is what Px, which is the horizontal force, is given by WC L square by 8H in whenever you have a cable which is carrying a uniformly distributed load. So we can consider our tendon, which is in a parabolic profile, that this is acting like a cable, and what is happening? It is taking per unit run of WC downward loads. So it will obviously have the same, it will act similar to the cable. So we have a horizontal thrust which is given to us to be WC L square by 8H. So we can consider this Px to be P, because we have here, since we are giving pre-stressing force, this pre-stressing force is also going to act here after you give a pull to this tendon, parabolic tendon. You will have what? This, when you're giving tension here, this P is going to act horizontal. So Px, we can write this Px, which we considered it for the horizontal reactions in cables. We know Px is WC L square by 8H. So this Px, we can consider it to be P. Now from this expression, we can find out what is our WC, that is the load, upward load per unit run. Okay, so hence, what is this? Hence, a parabolic tendon carrying a tension P will provide an upward uniform. Yeah, as I told you, that this is your upward thrust, which in a parabolic profile, you are going to get your upward reactions, or you can say upward forces, due to the pre-stressing force, which is HPH by L square. In this way, earlier in your this triangular bend tendons, you got how much your upward thrust to be. You would calculate it by 2p sine theta. Sine theta. So now in a parabolic profile, you will have a upward thrust of HPH by L square. Okay, so the net downward load obviously would be, if you have a load of parabolic, you have a parabolic profile of tendon and you have a load of W per meter length, then you can find out W per meter length, then you can, obviously you have a upward thrust in your bend tendon, parabolic bend tendon also. So that is WC by, sorry, WC per meter run. WC, sorry, this is C. WC per meter run. So this is going to counterbalance this load, and the remaining load, whichever is your remaining load, that we are going to consider, and because that only, that W, which is your W minus WC, this load, which is your total downward load minus your upward load, the remaining load will be acting now on your beam. Okay, so this is how when you have a parabolic profile, what happens? You have, this is the formula, you can say, how you can find out your, calculate your upward thrusts. WC L square by 8H. There is nothing difference than the bend tendon, but the concept is same, that in a bend tendon, when you give a tension, when you give tension, what will happen? They will give an upward pressure and they will try to counterbalance. The concept is same, that this, due to this pulling, and when you release these tendons, they will have a pre-stressing force, and this will try to, which is acting per unit run in this way vertically. So that is trying to counterbalance your downward loads. Same thing, only difference of a parabolic profile and of a triangular profile. And one more thing, these things which we were talking about in, suppose the bend tendons, in a triangular profile, in a parabolic profile, these are the methods. The name of this method by which we are uh, finding or calculating the stresses is what? The load balancing method. Okay, because there is an downward load, there is an upward load here, so they are trying to balance. So this is the method, is load balancing method, you can say. Okay, they are trying to balance. So because I think in your this the first class, maybe I think, or the second class, I told you that there are three methods of calculating or finding out the stresses in pre-stress concrete member. What was those? Those were your stress concept method. Then we had what? Load balancing method. The last one was your C line, you can say, or you can say it to be strength concept method. Lot of names are there for your this third one. So this is your first, second, and third. So stress concept was what? When we had no bend tendons, the sorry, in the bend tendons also you can solve the stresses by stress concept method. Okay, because in stress concept method, what was the stress concept method? You used to calculate the stresses at the top and stresses at the bottom. And what were those stresses? You know, the direct stresses, where there, if there is a load, there is a stress due to the bending moment. If there is an eccentricity, there is a moment of eccentricity. And so due to that, stresses are developed. So that was your stress concern method. In load balancing method, what we have done, upward thrust and the tendons or the profiles are giving you upward thrust, and they are trying to counterbalance this downward loads. Okay, so these are your nothing but the things, the last previous class which we have done in the last class with the triangular bend tendon, and now with the parabolic profile. These are the second method, which is load balancing method, since they are trying to counterbalancing this load. But actually, in a load balancing method, they are trying to totally neutralize the loads from the top, from the upper external downward loads. Okay, so that is, we'll talk about the load balancing method where we can in details after this parabolic profile is done. Okay, so let me, okay, so we will do a question now on this parabolic profile. So do one thing, note this down, this question with the diagram. Okay, till then I'll take your attendance. Okay, so I'll take the attendance now. Okay, let me meeting. Okay, till then you write this, note down this question, and try to solve, because you know how to solve it now from the concept. But I'll just discuss with you this now. Just write the question and also try if you can to solve. Enrollment 44, 44, 40, 64 Kaputara,
64, ma'am.
65,
Yes, ma'am.
65 Limeka.
Yes, ma'am. 65.
Please tell me your enrollments. Okay, 67,
Present, ma'am. 67.
67, okay, 69 Tashi, 69, 70,
70, ma'am.
72,
Present, ma'am.
72.
72.
73,
73, ma'am.
74,
74, ma'am.
75, 76, 77,
Sir,
76, 69.
yeah, ma'am. 76.
She's present. Okay, if
Ma'am,
someone
77.
77, 76.
Present.
Ma'am, 78.
Okay, if some of you may have problem in your connection, so if you cannot, I think maybe you're not audible,
Yes,
then you can just type here also. Okay,
ma'am,
69.
78.
Wait, 67. Sorry, 60. Sorry, 75. Gyati absent. Okay, 678. Pane.
Yes, ma'am, present, ma'am.
Okay. 81. 81. 82.
82 present, ma'am.
75 present. Okay. 82 present. Bhuvan.
Yes, ma'am. 82 present.
Okay. 83.
Present, ma'am. 83 present.
84. 84. 85. 87. 88. 84 is present. Okay. 85 is also present. Qatar did Burma. Okay. 87. 88. 89. Sorry, 90. 89. 90. 91. 92. 9.
92.
Okay. 92 present. 93.
92 present, ma'am.
94. 94. 95.
95 present.
96. 97.
97, ma'am. 97.
Okay. 98.
Present, ma'am. 98.
98. 100.
Present 100.
102. 100 is present. 102. 103. 105. 107. 110. Banserlinga. 10. 110. 112. 115.
112.
115, ma'am.
112.
115. 116. 116. 117. 119. 121. 122.
122 minutes.
122. 123. 123. 125. 126, 127, 128, 129, 130,
130, ma'am.
present 132, 135, 137, 139,
Yes, ma'am. 137, ma'am.
137, 1, okay, 139, 115 is leaving, 144, 140,
Ma'am, 117 present.
117, 139, 140, 142, 47,
Ma'am, 142.
42. Okay, integrated 147 is present. 1, 2, 3,
3
5.
present.
Ashram
3 present.
present. Chosin, Tasika, Michael.
Michael is present, ma'am. Michael is present.
Okay. Tashika, Chosin. Okay. I'll just let me type here. Absent. Those who are I'll just tell the absentees. Okay. I'll just call out the enrollments. 44 absent. 81 absent. 87 absent. 88 absent. 89, 90, 91 absent. Then we have 94 absent, 96 absent, 102, 103, 105, 107, 110 absent, 116 absent, 119 absent, 121 absent, 123 absent, 25, 26, 27, 29 is absent. Then 132, 135 is absent, 139, 140 is absent. Then we have Tasika absent, Johnson absent. Okay. Anybody left out? Have you solved the problem?
Yes, ma'am.
How much is your, what was the question? Calculate the extreme stresses of the mid-span section. So what is your stresses? Top stress and bottom stress?
Ma'am, top stress is 6.5.
Hmm, 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 hmm.
But bottom stress is 1.77.
Yes, correct. Others, did you get this? Hmm? Okay, I'll just show you the solution. Top 6.5. Affordable. Normal is yes. Yeah. Bottom 1.77. Okay. It's correct. See. We had in the question, the area was given to us. We had the section modulus BD square by 6. So we got our area, we got our section modulus. We have the span to be 6 meter. Then we have the dip is given to us 100 mm. Okay, so upward uniformly distributed pressure provided by the cable will be how much? We know it is given by HPH by L square, and HP is already known to you from the question. It is 1000. H is the dip, you know, 100 mm. That means in meter 0.10. L square, you know the span. Easy it is. Just put the values and you will get the upward total uniform distributed upward pressure. Then that means what? Now the total downward load is 35 kilonewton and the downward load is 35 kilonewton and the upward load is how much? 22.2 kilonewton. So the net load which will be acting now on your beam will be how much? This 35 minus your this thing 22.27. So that is 12.78 kilonewton per meter. That means now the load which is acting is 12.78, and due to this we'll have a moment. That moment is given by, since this is a UDL, so WL squared by 8, and we got our moment to be 57.51 kilonewton meter. So extreme stresses will be what? P by A plus minus M by Z. Okay. So that is how much? This much, 4.17 plus minus 2.40 Newton per mm square. So the extreme top stresses, this plus this plus this 6.57, this minus this bottom stress is 1.77. However, we know that our total stress which is acting on the beam is under compressive. Okay, this is compression is there on the entire beam at the top with a compressive stress of 6.57 and at the bottom 1.77. Okay, so this was your, whenever you have a parabolic profile, you just need to know the upward, this thing, upward uniformly distributed load, which is trying to counterbalance the downward load. Okay, So next we will see load balancing method. So basically, actually, load balancing method is nothing but we were the thing which we were discussing now, that was a kind of load balancing method. And actually, in load balancing method, what we do, we try to neutralize completely the upward and the downward load. Suppose your if I say your downward load, suppose here if your downward load is 10 kilonewton, so we will try to neutralize this by giving an upward load of 10 kilonewton. Sorry, sorry. So what happened is load balancing method is what we are trying to neutralize the downward load with the upward load. Okay, so in actually load balancing method, since we will try to neutralize the downward load. What we are going to do for that, we have to design also that profile such that it gives that much of upward pressure, so that it can resist, or it can counterbalance the this 10 kilonewton. Okay, before what we were doing is that we know the downward load, and we calculated the upward load. Okay, we calculated the upward load, so it may be 9 kilonewton, it may be 8 kilonewton, which is trying to counterbalance the load. Okay, so what is happening, so what is happening, yeah, the 10 kilonewton downward load and the upward load is here 8 kilonewton. But when we are trying to completely balance, what we will do, we will find out how much pre-stressing force is to be given. Earlier we knew the pre-stressing force, that this much pre-stressing force is there, this much dip is there, so we could calculate the upward thrust. Okay, but when we want to totally neutralize, if 10 kilonewton external load, downward load is there, and we want to give an upward load of 10 kilonewton, what is happening is that we will, excuse me please. so sorry for the disturbances. So what I was telling, yeah, about the load balancing method. So we'll try to neutralize the load balancing method. In load balancing method, we'll try to neutralize the downward load with the upward load. So what will happen here is that we will design the dip. That means we will give how much dip is required and how much pre-stressing force is required, either pre-stressing force or the dip, how much dip must be provided such that your this upward load is exactly 10 kilonewton, so that it will neutralize. When you give a 10 kilonewton now, it will neutralize the load. So load balancing is nothing but we will try to completely neutralize the external downward loads. Okay, when we do a problem on this, you will know. Okay, basically this were all the load balancing concept method. We have solved all this by load balancing concept. But when we need to neutralize, what we do is, see here in this question, if we take this particular question, here it is mentioned what determine the profile of a load balancing cable. See here in this particular question, you are asked to determine the profile of the load balancing cable for a beam of span. This is 6 meter carrying an inclusive load of 40 kilonewton per meter. The pre-stressing force in the tendon is 1200 kilonewton. Okay, so the beam section is 400 mm into 600 mm. So here basically what you have given the pre-stressing force is given to you, the span is 6 meter given to you, you have an inclusive load of 40 kilonewton. That means the external downward load is 40 kilonewton, and you have a parabolic profile here which has a dip of h. Now how much dip is to be provided such that it will give the upward pressure which is equal to this pressure, so that we have to find out. In some cases you would like to neutralize completely the external downward loads, in some cases you will want that. So in that case what you can do, you can calculate how much dip you can give, how much dip you need to how much dip you have to give to your tendons such that it is going to provide 40 kilonewton per meter of upward load, so that it will neutralize your loads. Okay, so what we are going to do is that we are going to just equate it. We know now in a parabolic profile what is our upward pressure. Upward pressure will be your hph by L square. So we know our pre-stressing force, but we don't know our dip. So what we are going to do is we are going to calculate the dip. We need to calculate the dip, right? So that much dip, if we provide this much of dip, what will happen? It will neutralize this 40 kilonewton per meter. So in order this upward pressure may fully balance the extreme load, we have to equate this one, which is your, this was your upward load, upward pressure, this one 800 pH by 3. So if we equate it with this, we can easily calculate our dip, this one, H. We got our H to be 0.15 meter. Okay, so that means what? We need a dip of 0.15 meter to neutralize this load. That means this 40 kilonewton and giving an upward force of 40 kilonewton. So we are trying to balance that. So we will assume that this is equal, and then equating this two we will get our dip. Okay, so in this way you have to find out the dip of a profile, and then you can easily find out what are the stresses developed here at a dip of 150 mm. Now once you know your dip, you can easily calculate, which is P by A, that is 5 Newton per mm square, which is compressive. Okay, after neutralizing also due to the some kind of dead loads, you will have a pre-stress of, sorry, the stress, normal stress, direct stress of 5 Newton per mm square. That means, okay, fine. Is it okay? Okay, whenever you are not given a dip, you can find out by load balancing method. That means we are balancing the load completely. That means the upward load is equal to the downward load. In that way we can design, or it can be like this, that you are asked the pre-stressing force, you are given a dip, you will be given a dip, you know this much dip, you are restricting your dip to be suppose 150 mm. you want that your dip must be 150. Now what must be the pre-stressing force such that your this load is equal to your downward load? So in that way we can provide, similarly we can equate it here, and then we can find out the pre-stressing force that must be applied. Okay, that must be applied. So this is the thing which you this is the load balancing method. Okay, another question, if you want, you can see this question, this one here. It has what? It has a parabolic profile. In this case what we do, 2p sine theta was our upward load. If we calculate it, 2p sine theta, what is having? 2phl. Okay, so 2ph, if we equate it with your upward downward load w, what is happening? We will get our dip h. So here is that we have equated our upward load with the upward downward load. So we got our h to be this much, wl by 4p. That means your dip must be wl by 4p if you want to completely neutralize the load. Okay, is the meeting going on? We are having problem connecting to the network. Hello, am I audible? Hello, or I am disconnected. Hello, 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 am I audible? Hello.